one more identity we want to verify. We want to verify the identity that for any triangle, so that adds a new element here. We're talking about an actual triangle with angles. For any triangle ABC, the sine of A plus the sine of B minus C is equal to 2 sine B cosine C. Okay, well, that's interesting, right? So let's take a look at where we might want to go with this. There's a couple of important things that come up in this proof. One is the fact that they told us we have a triangle. Okay, and how that will help us is, notice on this side we have just B's and C's, and here we have just B and C, but here we have an A, and that's kind of causing a problem for us because it's going to be hard to get that to go away. But we do know, since these are in a triangle together, that A plus B plus C should equal 180 because A, B, and C are angle measures in a triangle. Remember, angles in a triangle have maximum sum, the exact sum of 180. So we can write A in terms of B and C, right? If we solve this for A. Okay, so to do that, if we subtract this B plus C from both sides, we will have A. A is going to be whatever 180 minus B plus C is, and we've used that 1,000 times when we've worked with triangles. We had two angles, we added them together, subtracted them from 180 to find that missing angle that was still there. It just looks a little different here. Okay, and then what we're going to do with that is, since this is in a triangle, we know A should be 180 minus the other two angles added together. We can substitute that for A so that we are only dealing with B's and C's. We have this 180 here, but we know what the sine of 180 is, and that can work itself out. Okay, so we're replacing our sine A with the sine of 180 minus B plus C. Okay, and then we still have plus sine B minus C equals 2 sine B cosine C. All right, let's expand this a little bit. Okay, let's expand the sine of 180 minus B plus C. Okay, well, we know we have an identity for the sum of two angles, the sine of the sum of two angles, and it is the sine of the first angle, so sine 180, times the cosine of our second angle, which was B plus C, minus the cosine of that first angle, so cosine 180 times the sine of the second angle, which was B plus C. So that is just this part expanded using our sums. Plus, we still have this sine B minus C on the end, and it's equal to, or we're hoping it's equal to, the sine of B times the cosine of C. Okay, from there let's simplify a little bit. So the sine of 180 is 0, so this gives me 0 times cosine B plus C. Okay, minus cosine of 180. Instead of sine 180, cosine of 180 is -1, and that's times the sine of B plus C. And then we still have plus sine B minus C on the end down here. We're trying to prove it's equal to 2 sine B cosine C. Well, 0 times anything is just 0, so this would be 0. Negative times a negative is positive, so I have the positive sine B plus C plus sine B minus C. And again, I'm trying to prove that's equal to 2 sine B cosine C. Now, remember we had our product to some angles, right? So now we're down to 2 sine B cosine C. Well, remember our product to some identities, they have a 1/2 here. So what if we divided both sides by 2? Then we would have 1/2 of sine B plus C plus sine B minus C equals sine B cosine C. Is that one of our identities? Okay, so I've noticed I've dropped our identities right down here just so we could double check and make sure we do have it. So sine B cosine C, what is that supposed to be equal? Well, sine of an angle, cosine of the other angle should be 1/2. Got that. Sine of the first plus the second, so our angles are B and C, so sine B plus C, we've got that. Plus, check, got that. Sine of the first minus the second, so sine of our B minus our C. So that is exactly right. So we have sine B cosine C right here. And we have proven our identity. It took a little different method. We had to substitute from our knowledge of triangles up here at the top, but then we were able to expand and come down to a product and sum identity.